For this example, we have to find the arc length for the curve. So first, let's just recall the formula. So the arc length would be the integral from a to b, square root of 1 plus dy over dx squared dx. I like to do all the preliminary work before I actually plug it in for the integral. So you see right here, y equals to x plus 4 to the 3 half. We can take the derivative, dy over dx. It's going to be 3 halves x plus 4 to the 1 half. And then we're going to have 1 plus dy over dx squared. So if I plug it in, I get this, x plus 4. So let's simplify this. So I get 1 plus 9 over 4, x plus 9. So it's going to be 10 plus 9 over 4x. Now I'm ready to plug it in. So the length is going to be from 0 to 4, the interval from 0 to 4, square root of 10 plus 9 over 4. So I'm just going to go ahead and write as the fractional exponent, which is 1 half dx. So you can see that we have the u substitution here. So u is going to be 10 plus 9 over 4x. So du is going to be 9 over 4 dx. Okay, so we're going to have to take care of that for 9. 9 over 4, so I have to multiply by 4 over 9. So when we take care of the integral right here, I'm going to have 4 over 9 for this one. And we do 1 over 2 plus 1. So that's 3 halves. Divide by 3 halves. So I ended up with 2/3. And we have 10 plus 9 over 4. X to the 3 halves. And we want to evaluate from 0 to 4. Let's simplify. So I have 8 over 27. Ten plus 9/4 x to the 3 halves. So when I plug it in, I'm going to get 19, 3 halves, minus 10, 3 halves. And I'm just going to leave my answer in the exact form like this. For this problem, we have to find the arc length for the curve y equals to x cubed divided by 3 plus 1 over 4x from 1 to 2. A lot of these problems, I believe, is the tough part is the algebra part. So if that's the y functions, when we take dy over dx, we're going to get x squared minus 1 over 4x squared. So I need to take 1 plus dy over dx squared. So it's going to be 1, and if I FOIL, I should end it up with x to the 4th minus 1 half plus 1 over 16x to the 4th. Hopefully, you can see that you can factor this and make it into a perfect square binomial. But first, let's take care of the 1. this one right here. So if I simplify, I have the 1 minus 1/2. So we ended up with x to the 4th plus 1/2 plus 1 over 16 x to the 4th. Now I can factor. So x squared plus 1 over 4x squared squared. This turned out to be so much easier when we take in the arc length, because when you take the arc length, you take the square root of 1 plus, this is a formula, 1 plus dy over dx squared. So what we have, when you take this, you plug it in, since we have the square and the square root, it cancel out. So I have the absolute values of x squared plus 1 over 4x squared dx. So when you integrate that, so this is what we need to integrate. Since it's x squared, I can just drop the absolute values. So it's going to be 1/3 x cubed minus 1 over 4x. And then we want to evaluate from 1 to 2. Okay. So if I plug it in, I should get 8/3 minus 1/8 minus 1/3 minus 1/4. And all of that going to be equal to 59 over 24. I want to try a trig function. So for this curve right here, when you take dy over dx, you're going to get 1 over cosine of x. And then doing the chain rule, I get negative sine of x. So this one turned into a negative tangent of x. Therefore, 1 plus dy over dx squared is going to be 1 plus tangent square of x. Hopefully, you recognize that's just secant square of x. Therefore, the arc length is going to be from 0 to pi over 3 square root of secant square of x dx. That means we have the integral from 0 to pi over 3 secant of x dx. And when you take the antiderivative, we ended up with ln, absolute values of secant x plus tangent of x. And we want to evaluate from 0 to pi over 3. So when I plug it in, I should get ln 2 plus radical 3 minus ln 1 plus 0. So to simplify that, I ended up with ln 2 plus square root of 3. And that's my final answer. This problem requires a lot of algebra work. So first, let's take the derivative. What we have for dy over dx is going to be 1 over 1 minus x squared times negative 2x. So if I square that, negative 2x over 1 minus x squared. So this is the arc length, 1 plus dy over dx squared. It's going to give me 1 plus negative 2x over 1 minus x squared. And then we have to square this. So if you square that and you you do the LCD for the 1 here, we're going to end up with square root of 1 plus x squared over 1 minus x squared square. So now I can cancel out the square and the square root. I ended up with 1 plus x squared over 1 minus x squared. So now, since we have the division, we can do long division. When you use long division, 1 plus x squared divided by 1 minus x squared. So you see right here, we have a negative, we have a positive. So I have a negative 1 here. So negative 1 times 1 is negative 1. Negative 1 times x squared is x squared. So when you subtract, you ended up with 2 for the remainder. So now the new fraction here is going to be negative 1 plus 2 over 1 minus x squared. Now we're going to have to do partial fraction. This one. So you can see that we have 2 over 1 minus x, 1 plus x, and 1 minus x. So what I have is a over 1 plus x plus b over 1 minus x. Multiply everything by the LCD. I get 2 here. A, we have 1 minus x. And then for b, we have 1 plus x. If I let x to be 1, a will cancel out for this one. So b is going to be b times 2. So b is going to be 1. Now we do the opposite. I'm going to let x to be negative 1 to cancel out b. So 2 is going to be 1 minus negative 1. So that's plus 1. So a is also 1. Now we're ready to rewrite our fractions. So we have negative 1 plus 1 over 1 plus x plus 1 over 1 minus x. So the length is going to be from 0 to 1/2. Negative 1 plus 1 over 1 plus x plus 1 over 1 minus x dx. So we can just integrate that. When you integrate, you ended up with negative x plus ln 1 plus x minus ln 1 minus x. It's because of this minus right here. So that's why I have the negatives. And we integrate from 0 to 1/2. So we have negative 1/2 plus ln 3/2 minus ln 1/2 minus 0. And then we simplify that. We ended up with ln 3 minus 1/2. And that's my final answer.